Hi, welcome back to this mock review. I'm going to go through question 5 now. So we begin here by trying to use the normal distribution to find the probability that a random battery lasts longer than 16 hours. We'll need to begin by setting up our model, and L can be modeled as a normal with a mean of 18 and a standard deviation of 4, so a variance of 4 squared. The probability that L is greater than 16 is equal to 1 minus the probability that L is less than 16. And we can find this probability using the calculator. We can just go into the binomial CD and get that result, which is 0.3085 and a lot more numbers. Using that, we get 0.6914 for example, maybe round that off to 0.6915 to 4 decimal places. Now on to part B. At the start of the exams, Alice put 4 new batteries into her calculator. She's already used it for 16 hours, but has another 4 hours to sit. So, find the probability that her calculator will not stop working. We need the probability as a conditional probability, given that we want the probability it can last the 4 hours is equal to the probability that it will make it to 20 hours. So probability that L is greater than 20, given that L is already greater than 16. And referring back to the formula for this, we can see that we need to have the probability that it lasts over 20 divided by the probability that it lasts longer than 16. So I want probability that it lasts longer than 20 over the probability that it lasts over 16. We've already got the first probability, and we can easily use the calculator to get the second one, or indeed you can use your knowledge of the normal distribution to work out that because it's symmetrical, the probability that it's over 20 will be the underlying value above. So that gives us 0.3085 to 4 decimal places divided by 0.6915, and we can just calculate that, and we get 0.4461 to 4 decimal places. But that's not the end of the story. She has 4 batteries in there, and each of those 4 batteries has to last. So this is the probability for a single battery. We need that for 4 batteries, so we're looking for 0.4461 to the power of 4 for all 4 batteries to last, and that is 0.03961, or something that rounds to 0.396. So Alice decides to replace 2 of the batteries. That means that now the calculation that we have is that we have to get 2 new batteries to last longer than 4 hours. So that's 2 of those. And we also need to take 2 of the old batteries and check that they last. Well, those we already know, that's 0.4461 squared. So we need to calculate this. And again, we can go straight to the calculator and get that value. Remember, it's 1 minus. So I'll just do that. The probability that L is greater than 4 is equal to 1 minus the probability that L is less than 4. And that is 1 minus 0.233. Well, sorry, lots more zeros. Just 0.00023, lots more, is 0.99977, roughly speaking. I'm going to round that off to 4 decimal places and use that in here so that we get 0.9998 squared times 0.4461 squared. And we can just do that on the calculator. And that gives me 0.1989. I don't fancy her chances of getting through the exam without her battery breaking down. Okay. So final part D. After the exams, Alice thought that there might be something hinky about the lifetime. She thought it would be greater than. So we have to complete a normal distribution test, a hypothesis test on the normal distribution using a sample. We have to remember the things that come from that. So L is modeled as a normal distribution with a mean of mu and a standard deviation of 4, so variance of 4 squared. Our hypotheses are that the probability, the mean, is equal to 18, and our alternate hypothesis is that it is more than 18, because that's what Alice has written up there. So that would be mu is greater than 18. This is a one-tailed test, and we're doing this at 5%. We also have a sample mean given to us that we can test. So we need to create a sample distribution. So L bar, if we assume H naught, then L bar can be modeled as a normal with 18 and a variance of 4 squared over 20, because n is 20. That's the number of the sample, because it tells us that up here, and that's really important. We now need to find the probability that the mean is greater than 19.2. And if we do that on the calculator using this distribution, we get 0.0898. Now, using that and comparing that to our 5%, we need to decide if that's significant. Well, this is nearly 9%. This happens nearly 9% of the time, according to this. This value would occur around 9% of the time, the 19.2. This is telling us it happens around 9% of the time. We wanted it to be 5%. Therefore, there is not evidence to reject H naught. 0.80898 is greater than 0.05. Therefore, no evidence to reject H naught. Okay, and now we need to state that in context. There's no evidence to suggest Alice is right. Nothing to support Alice's belief. There's no evidence to support Alice's belief. Oh, if you use the right pen, it's better. Okay, so thank you for listening to all of these. I hope that's all clear. Do come and ask your teachers for support or help on anything you didn't get. And let me know if I've made any mistakes in the video. Thank you. Right.